Alright, example 3 is the same thing. We're going to do cosine and tangent at the 4 quadrant angles. So, looking at our 4 quadrant angles, 0, pi over 2, or 90 degrees, pi, which is the same as 180, we label them here, 180 degrees. This is also 90 degrees, and down here 3 pi over 2, which is 270 degrees. And so we want to find the cosine and the tangent at all of these. So let's start with cosine. I'm going to make a little table here. Let's do 0, pi over 2, pi, and 3 pi over 2. Alright, all of our options. So cosine at 0, we're looking for the x value if we're talking about cosine. So in this case, our x is 1. At pi over 2, the x value is 0. When we go over to pi, our x value is negative 1. And when we come down here to 3 pi over 2, or 270, we go back to 0 for the x values. Alright, now really quickly, before we do tangent, I'm actually going to do sine as well, because that'll make it easier for us to do the tangent. So let me erase these. The sine is going to be the y value. So our y value here at 0 is 0. And then our y value is 1. And then our y value is 0. And then our y value is negative 1. Alright, so tangent then becomes easy because it's y over x, or sine divided by cosine, seeing as sine is y and cosine is x. Let's go ahead and divide. 0 divided by 1 is 0. 1 divided by 0 is undefined. 0 divided by negative 1 is 0. And then negative 1 divided by 0 again is undefined. So an easier way to remember this is that anytime your x value is 0, tangent is going to become undefined. So knowing that, let's see if you can tell me the sine of pi. Well, that becomes really easy. We just did it. Pi is over here. The value back here is negative 1 comma 0. So the sine right there is the same thing as saying what's the y value, and the y value back at pi is 0. So the sine of pi turns into 0. Alright, let's move on to reference angles. A reference angle is going to be the little helper angle that lets you make a nice right triangle. So if you notice, and I kind of skipped over this when we did the original problems, we have this angle here that starts, remember we always start on our positive x-axis, and spins over to our terminal angle. Our terminal side is over here. Now that is not a right triangle. Right? That's a big obtuse triangle if we had to connect it along here. We don't want that. What we do want is the nice right triangle that's made over here. But our angle in here, theta, is not the same as this theta. So what we're going to do is call this little angle in there theta prime and say that's the reference angle. All right? And so the reference angle is however many degrees or radians is left over to complete that right triangle. So in this case, if we had an angle here, we would want to say, okay, 180 minus this big angle would give us our reference angle. Okay, but it's not always 180 minus. In this case, it's 180 plus whatever little thing is left over there to get us our helper angle, which we're going to call reference angles. Okay, so let's do a couple examples and see if we can make sense of this. Let's find the reference angle for 300 to start with. Alright, so 300, let's pop it up there. There's 300 degrees. 300, if we spin around, there's 90, 180, 270, and if we keep going, another 30 gets us to 300. So as I counted, I went 90 degrees, then another 90 for 270, then another 90 for, 90, 180, then 270, plus another 30. How much is left over to finish off our angle? 60 degrees. So in this case, the reference angle, theta prime, that's what we mean when we have this little dash up there, is 60 degrees. All right? Now 2.3 is a little trickier. 2.3 is an angle in radians. We're not exactly sure where that is, but remember that pi is about 3.14. So pi over 2 is going to be half of that. Call it 1.6-ish. Okay, 1.5-ish. So 2.3 is in between those 2 points. And if pi is over here and pi over 2 is up at 90, then 2.3 must be somewhere in between those two. All right, so my angle is 2.3. I want to know what's the remaining theta prime in here. What's the leftover part? Well, it's going to be pi minus 2.3. Okay, pi minus 2.3 will get us whatever the remaining angle is. And we can leave it just like that because that's an exact answer. All right, let's finish this up. Negative 135. So we're going in the negative direction. As we spin, there's 90. And I'm not going to make it all the way to 180. So here's theta, negative 135. So to make our right triangle, we want to know about theta prime in here. So in that case, I want to know how much more would be required to get to 180 degrees. All right? So negative 180 degrees would be comprised of theta prime and then plus negative 135. All right, so to solve this, we can add 135 to both sides. And what we'll end up with is negative 45 degrees for theta. Would be our helper angle. We don't want to use negatives for our helper angle. We want to say we would go another 45 degrees in the negative direction. So really, 45 degrees is the reference angle we're looking for. Just want to use positives so that we can go back and think about these triangles in terms of what would they be if we drew them in quadrant 1. Okay, that way we only have to remember the x and y values for quadrant 1. All right, so try it on your own for problem 45. Go ahead and find the reference angle and then sketch theta and theta prime. All right, 160 is going to be in quadrant 2. It's more than 90, but less than 180. So I want to know theta prime. How much more do I need to go to get to 180? Well, if I've already gone 160, then theta prime is going to equal 20. And I can check that by saying 20 plus 160 equals 180. And if I look at my two angles, theta plus theta prime gets me to a half circle, 180 degrees. All right, so there is a chart in here in your book. You can go back and reference it if you need to, but it does have all of your values for 0, 30, 45, 60, 90, and then the rest of the cardinals, 180 and 270. This is worth remembering that the sign of 30 is 1/2, and then it goes up. And so there's also a little cheat sheet in your book. If you can memorize this as it counts up our important angles, 0, 30, 45, 60, 90, the sign is the square root of 0, then the square root of 1, then the square root of 2, then 3, then 4. And this does simplify. The square root of 1 is just 1. So if you look at the sign of 30, you get 1/2. But remember, that's the square root of 1 over 2. Square root of 4 is the same thing as saying 2. So 2 over 2, sine of 90, is just 1.